No matter what operating system you use, when it comes to Wi-Fi, it has a way to tell you the current physical speed. For example, I'm using Mac OS. For the Wi-Fi, it can tell me this very detailed information. Here you can see the TX rate, the data rate for transmitting or sending. In the lower left part of the screen, you can see a third-party tool. For my case, it's from Ubiquiti. It displays the current Wi-Fi signal, the download speed and upload speed. Again, they are the physical speed, not the real world speed you can achieve. In the upper left part, I show you my Wi-Fi access point. It tells you the information from the AP perspective, RX rate and the TX rate. They are all physical rate or theoretical maximum speed. You may wonder where they are coming from, how you can tell the speed by yourself. So in this video, let's talk about that. I'm going to use Wireshark to capture the wireless frames to show you how to tell the physical speed. In this video, I'm not going to discuss the details how to capture Wi-Fi frames. If you are interested, check my another video. This is my lab environment. I use a UniFi U6 Enterprise access point. It supports the Wi-Fi standard all the way to Wi-Fi 6E. I connect this AP to a UniFi switch and then to a UniFi router. I'm going to test 3 different Wi-Fi clients in order to show you the different Wi-Fi frames in different Wi-Fi standards. They will be connected to the access point using different frequency of signals. You may ask why you don't show the Wi-Fi 6E. This AP does support 6E, right? There are 2 reasons. First reason is the Wi-Fi 6E and Wi-Fi 6 are all using the same standard, the 11AX, so the frames should be the same. The second reason is I'm going to use the Mac OS built-in sniffer to capture the wireless frames. Unfortunately, in the newest Mac OS and the newest Apple hardware, when it comes to sniffer, it doesn't support 6 GHz, so I won't be able to capture Wi-Fi 6E frames if I use the 6 GHz frequency. So that's why I'm going to only show these 3 Wi-Fi standards. To capture the data frames, Wi-Fi clients need to communicate with the other devices. So I have a Linux virtual machine connected to the UniFi switch, and I'm going to use this Linux to communicate with these Wi-Fi clients. On the screen, I show you the desktops for the 4 Mac machines. I already displayed the current Wi-Fi status. As you can see, they are connected using the corresponding Wi-Fi standards. The top right one, 802.11n. The bottom left one, 802.11ac. The bottom right one, 11ax. The top left one is the sniffer Mac machine. We are ready to capture Wi-Fi frames. As explained in the diagram, I'm going to connect the 3 Wi-Fi clients with this Linux machine so that I can have some data frames among these machines. Here in the top left Linux machine, you can see I already started 3 iPerf3 servers. Each one is listening using a different port number. And now I'm ready to start some data communication among these 3 Wi-Fi clients with this Linux virtual machine at the same time. So start with the very old Mac. Yeah, started. Then the Wi-Fi 5 Mac. Then Wi-Fi 6. Okay, you can see they are busy sending and receiving data frames. As mentioned, I won't talk about the details how I capture Wi-Fi packets. Now I have the 3 different sessions captured already. To know the data rate, you have to have some basic understanding about MCS index. This is a web page from Wikipedia. It talks about the modulation and coding schemes. There are a lot of terms here, but let's briefly talk about several of them which are related to this video. The MCS index, later you can see we can directly get it from the Wireshark captured Wi-Fi frames. It's just index. It combines the combination combinations of the other important parameters. Spatial streams. To put it simple, you can think about how many concurrent connections you can have between the access point and your Wi-Fi device. The megahertz part is the width of your channel. You can get it in your Wi-Fi setting. That's very important when you set up your access point. And the GI means guard interval. Basically, it means what's the gap between this data send and the next data send. Apparently, the smaller the number, the faster the speed. What we want to do in Wireshark is to get the MCS index, channel width, GI. We need to know the spatial streams. Then we can simply refer to this table to get the data rate. Now on the same screen, I show you 3 Wireshark windows for the 3 different sessions we captured for Wi-Fi 4, 5, and 6. Wi-Fi 6 frame structure is more complicated and Wireshark has better description. So let's start with Wi-Fi 6. As you can see, for all the 3 Wireshark windows, I already filtered the frames by using the Apple machine's address and the Linux virtual machine's address. Now you only see the frames we are interested in. The next thing we want to do is we want to make sure we check the data packet. Let me pick a random one. Go to the IEEE 802.11 section, expanded, see the frame control part. You can see now the value is 2, which means it is data frame. Now we are ready to start finding the important parameters we just talked about. First, MCS index. Go to the radio tab header. Under HE information, there are multiple data section. Go to data 3. This parameter, data MCS, is hexadecimal value B, which means 11 in decimal value. Then go to data 5. See the GI value is 0, which means 0.8 µS. Above it, you can find the channel width. The value is 2. It means 80 MHz. We get the third important parameter value. The last parameter value to find is the number of spatial streams. So let's go to the data 6 section. See the value here. Count is 2. We have 2 spatial streams for this Wi-Fi 6 scenario. Now we have all the parameter values we need. Let me go to mcsindex.com. You can see this complete reference table. Let's use our values to look up the data rate. If you remember, we get the MCS index as value 11, right? You can see 3 different columns under MCS index. Which one you should use? For our case, remember we just checked the Wi-Fi 6, and you can even see in the packet details we get the information from the HE information. So basically for Wi-Fi 6, you want to use this HE column. So your next problem is you see multiple 11 here. So which one we should use? You can notice the difference is in the spatial streams. The spatial stream count for our case is 2. We need to use this row. Now we are very close. Then the next value we want to use is the channel width. Remember it's 80, right? Under 80 MHz, we have 3 GI values. Our particular case, the GI value is 0.8 µS. So then we can locate this cell. This is what we want to find, our particular data rate for this particular packet, 1.2 gigabits. If you want to validate it, you know what? You can even directly get the value from the captured packet. Go to the radio information section. See, it directly tells you the data rate. It exactly matches what we just found in the MCS index. Of course, the whole purpose of this video is not just to find the data rate. We want to understand how the data rate is even derived or calculated. Okay, now we are good with Wi-Fi 6. Let's move on to Wi-Fi 5. It's slightly different than Wi-Fi 6. For Wi-Fi 5 and the radio tab header, you don't have the same HE information because it's different Wi-Fi standard, but it does have a VHT section expanded. Yeah, you see different structure as Wi-Fi 6. Under user section, you can find the MCS index. Value is 4. The spatial streams count is 2. Got the interval. The value is 0. But remember when we check Wi-Fi 6, 0 means 0.8 MUS. Channel width listed here as 80 MHz. We got all the 4 important values. Let's try to look up the data rate using the MCS index table. MCS index is 4. We need to use the VHT column instead of HE. So we see multiple 4 here. We need to try the correct spatial stream number. In our case, it's 2. So we want to use this particular row, right? If you move to the right, try to find the channel width, which is 80. The GI is 0.8 MUS. So we get this value, 351 megabits per second. That's our data rate. See the captured packet, it lists the data rate. It's exactly the same number we just found. Okay, for Wi-Fi 5, we are done. Now let's check the Wi-Fi 4 packet. Under the same radio tab header, I can't see the familiar structure as in Wi-Fi 6 and the Wi-Fi 5, so it's not as well structured as the newer standards. We can still find the information we need. Under MCS information, you can see the MCS index 15, GI value is 0. Remember that means 0.8 MUS. Then the channel width is 20 MHz. I don't see the value for spatial stream, but it doesn't matter because if we check the MCS index table, you can see under HT, which is for Wi-Fi 4 in our case, we do see only one 15 value, so no multiple options. We can directly know if MCS index is 15, the spatial stream is guaranteed to be 2. Then we know the channel width is 20 MHz and the GI is 0.8 MUS, so we know this is our data rate, 130. Whether it's correct, see the captured packet, data rate 130. Okay, so we are good for all the 3 Wi-Fi standards. We know how to look up the MCS index table based on the information we can gather from the wireless packets captured by Wireshark. Okay, thanks for watching.